So now we're doing the last part of the review, test one review. So we're on, let's see, what problem are we on now? We're on number 40. Okay. And they want us to find 5 solutions of the equation. Select integer values for x, starting with -2 and ending with 2, and complete the table of values. Okay, so I have the equation y equals 9x minus 8, and then I have this table here where x is first -2, and we have the equation y equals 9x minus 8. Okay, so what we're going to do is we're going to substitute, and everywhere we have an x, will sub -2. So y is equal to 9 times x. So 9 times -2 minus 8. And 9 times -2 is -18 minus 8. So that's keep and then change and then take the opposite. And a negative plus a negative, you owe somebody 18, you owe somebody else 8, you still owe them, so you haven't paid that back yet, so it's still negative. 8 and 8 is 16, carrier 1, 1 and 1 is 2. So that's negative 26. And if you're not sure, you can check your sign numbers. Negative 18 plus negative 8, you can see it's negative 26. Do a little checking there. Okay. So then your y is a negative 26. So then your ordered pair, x, y, when x is -2, your y is negative 26. Okay. Okay, then the next value they have is -1. So y is equal to 9 times x, and x is now -1 minus 8. Okay, so you get that from this equation. This is what was given to me. Remember, my test was generated, so I'm sure you have a different equation, maybe even different values here, maybe even. Okay, so y is equal to a positive times a negative is a negative minus 8. So y is equal to -9 plus -8. And so y is equal to negative 17 here. So when x is -1, y is negative 17. Okay, I also have x to be 0. So y is equal to 9 times 0 minus 8. And any number times 0 is 0. So that's just a -8, then 0 minus 8. So that's the value 0, -8. Then I have, let x be 1. Y equals 9 times 1 minus 8. So 9 times 1 is 9 minus 8. And 9 minus 8 is 1. So when x is 1, y is 1, so we have the ordered pair 1, 1. And then the last value they want x to be is 2. So y equals 9 times 2 minus 8. Y is equal to 18 minus 8. So y is equal to 10. So 2, 10. All right. Yeah, and they didn't ask us to graph this. They just said complete the table. Okay. But they didn't make us graph this. But if you were to graph this, you'd start at 0, 0, and here for x you'd have to move right, hold your pencil, and then you'd have to move down, and then you have to plot your point. Here you go to 0, 0. Here you'd have to move. This is left, right? You move to the left. I'm not sure if I might have said this wrong earlier, but you move to the left. Here you move to the left, and then you move down. Here, because it's 0, you do a stay. So you don't go right or left. Here you do a stay, and then here you go down. Here you start at 0, 0, you go to the right 1, and then you'd go up 1. And here you'd go right 2, and then you go up 10. And you should have a line. So these points, if we did all this math correctly, these points, these ordered pairs, should be collinear, which means they should form a line. Okay, some kind of a straight line, some kind of a slanted line. When you only have x's in the equation, or when you only have y's in the equation, then that forms either the vertical or the horizontal line. So earlier we saw in a previous recording earlier, see how this is a horizontal line right here for number 37. This happens to be a horizontal line. Notice how on your equation we have only y variables. Okay, and I think we had, let's see, oh, like also here, horizontal line, you have only y variables. That was for this is for number 35. Whereas over here on number 38, you have, this is a vertical line. And look at your equation. Look at your equation. You have only x variables. Okay. See here, number 39. This is a vertical line. And you have only, see, X variables. So like no Y's, no Y's. Okay. Okay, but for what we're doing right now on number 40, if we were to graph this line would not be vertical, it would not be horizontal. This line would be slanted, not vertical, not vertical like this, not horizontal like this, but it'd be some kind of a slanted line. And how do we know that? Because you have both x and y's in the equation. So this is going to form some kind of a slanted line. How do we know that? Due to both x and y variables if we were to graph that. So that you do want to know that. Okay. Okay, so that was 40. Okay, now we're going to go to 41. It says determine whether the statement makes sense or does not make sense and explain your reason. It says if I could be absolutely certain that I have not made an algebraic error in obtaining intercepts, I would not need I would not need to use checkpoints and choose the correct answer below. And I'm looking at the choices, and we want to say that this makes sense because at least 2 points are required to graph a line. Hmm. Well, and I think when I chose this problem, maybe I read it too quickly and I was thinking, usually the idea is that through any 2 points you can draw a line, but you are recommended to do a checkpoint and just as a check go ahead and use a third point to make sure that you do get a straight line or a line, and not some kind of a triangle or something. So that's really that was the intent of this problem. That on 41, it's true that through any 2 points, you can always, draw a line. but it is a good idea to use a checkpoint and find a third point. The points should be collinear and form a line. Yeah, so I think maybe I read that problem too quickly when I chose it. So it didn't really exactly convey the thought that I wanted to express, which was this right here. That, yeah, through any 2 points, you can always draw a line. And that's why it's good to do a checkpoint and pick a third point and make sure that you can still draw a line through your 3 points. Because if you can't, then you have a mistake somewhere. And then you should double check, all right? So any 2 points can always draw a line. And they use the word graph. I said draw, okay. All right, okay, let's look at 42 now. Okay, so 42 says they want you to, they have this table again that they want us to complete, but then this time they do want us to draw a line. So, okay, so we have y equals negative x plus 2. And so we have this table here with x values, y equals negative x plus 2. And they're going to let x be negative 2. So again, we're going to sub negative 2 into x. Okay, so we have y is equal to negative, and x just happens to be also negative 2 plus 2. Negative times negative is a positive. So now we have positive 2 now, plus 2, and then y equals 4. So when x is negative 2, y is 4, okay? And since they want us to graph it, I'm going to go ahead and start graphing it also. They have their graph there, so I'm going to start graphing that here. So this is my top of my liquid paper there. There's the top for that fell. Okay, so negative 2, 4. So you start it at 0, 0, and then negative 2 means you go to the left 2, negative 1, negative 2, right here, right? Then you hold your pencil, and then you go up 4. So 1, 2, 3, 4. So see, I don't put a point here. I just mark it here, but I don't put a point, okay? I don't put a plot a point till I'm done with y. I go up 4. And I'm going to label. Okay. So when I create the tests, I will likely have a template that will have graph paper built in, or I'll have you produce, your own graph paper, and then actually also plot it on the computer, or choose the graph on the computer, but then also you should be doing it by hand and submitting that also. So you do it by hand, then you also submit on the computer. Okay, so you should have some kind of graph paper, or print the graph paper that I've provided for you. Okay, so that's 42. That's at least for -2. Okay, so now we have -1. Y equals a negative right here, negative, and then a -1 plus 2. Negative times negative is a positive, plus 2, and then that gives you 3. So when x is -1, our y is 3. So here you'll go from 0, 0, you'll go left 1, up 3. So -1, -1 is right here. So you go left 1 and then up 1, 2, 3. Okay, then we have 0. Y equals a -0 plus 2. Now really 0 is neutral. I mean 0 is not really positive or negative. 0 is like a neutral number. So I'm going to just put 0 here, plus 2. Should just give us 2. 0, 2. So this tells you to stay and then go up. So stay and then go up 2. So you don't go right, you don't go left, you stay and then you go up. See, and that's looking good. That's looking collinear. Okay, then we have 1. So y equals the negative right here from this x, negative right here in front of the x, and then x is 1 plus 2. And that just gives us 1. -1 plus 2, you have adding two numbers with different signs. You have to decide on ID, your sign, and subtract. So you want to go with the one that's got the bigger absolute value. Then you're going to subtract. 2 minus 1 is 1. So here you go right 1, up 1 from 0, 0. So you go right 1, up 1, right 1, up 1. And again, that looks good. That's collinear. So right 1, up 1. And then the last point is 2. Y equals -2 plus 2. Okay. So -2 plus 2, that gives us 0. Those are additive inverses. A number plus its opposite zeroes out to 0. So you go to the right and then you stay to 0. So you go to the right and then you stay to 0. Yeah, and that looks good because it's collinear, which means you're able to draw a line, a straight line through these points. And then I always put arrow tips on the system. And then the name of this line is y equals -x plus 2, and this is a slanted line. It's not vertical, not horizontal, but it is a slanted line because you have x's and y's in your equation. Okay, now we're going to go to 43. Which asks, what's a y, what is a y-intercept of a graph? Okay, I'm looking at all my choices, and we're going to go with the saying that says that a y-intercept of a graph is the y coordinate of a point where the graph intersects the y-axis. Yeah, so it's the y-intercept. It's a location. Okay, it's a location where the graph, and they use intersect, so I can say crosses, where the graph crosses the y-axis. Okay, so y coordinate. Okay, so like for the previous problem we did on this number 42, see how your graph crosses the y-axis right here? This happens to be 0, 2. That happens to be the y-intercept. That's where the graph crosses the y-axis. And see this right here? This is the x-intercept. 2, 0. So this is where the graph crosses the x-axis. This is where the graph crosses the y-axis. So those are called intercepts. Okay. And sometimes you could get a fraction. These are nice counting numbers, counting numbers, natural numbers, right? And you could get a fraction sometimes. These are just nice. Here they intercept at those natural numbers. Okay, let's look at 44. If you are given an equation of the form ax plus by equals c, explain how to find the y-intercept, which has the format, they say 0b y-intercept. Notice how it's a lowercase b. That's not the same as the capital B here. Okay, so basically to do that in your algebra, to find the y-intercept, because it says 0b, what you would do is you would see, this is x, y. You would have to let x equal 0. So let x be 0. And you'd have to substitute for x the 0. And then you'd have to do your algebra and solve for y. See, solve for y, which they call it a b coordinate. And let's see, and we'll probably be doing that in a short while when I look at some of these other problems, but that's the idea that we're getting ready for. Let's see what 45 says. Use the graph to identify the x-intercept Or if it doesn't have an X-intercept, state that it doesn't have one. There's no X-intercept. And then use the graph to find the Y-intercept. If it doesn't cross the Y-axis, because sometimes it may not, then state that there is no Y-intercept. Okay, so let's see. I see that it's a graph. Okay, so I'm going to go back and go back and use this paper here, 45. And let's see. Yeah, and a good thing I left my other computer open because see, my graph came out really light. That's really, really light. See that? See that right there? That's the X-intercept and that's the Y-intercept. So I'm going to draw that. I have a better picture up here. So let's see. I can see that the point is intersecting. Let's see. It's at negative right here. So see it crossing right here. That's the graph that was given. And also right here. That's what I see. So I have that graph and it's going through those 2 points. And yeah, that kind of, I'm just recreating this also, okay? All right. And so then I'm going to say, the directions say use the graph to identify the X-intercept and then also Y-intercept. Okay. So again, the X-intercept is basically the location where the graph, crosses the X-axis. And you can see that here's your X-axis, that's right here. So that is -1, -2, -3. This is the point -3, 0. Okay, so I like to say that it's a -3, 0, but in the instructions, they don't want an ordered pair. And so of course you follow the instructions. They just want an integer. So they just want us to type an integer, and this is your X and this is your Y. So which integer do you type? Well, you want the X-intercept. Where does the graph cross the X-axis? So you want the X. If they say type an integer, you want to type in the -3, not the 0. Okay. If they wanted you to provide an ordered pair, if they said that, then which is what I like, teachers like, is -3, 0. But of course, if they have directions and they say, like this one says type an integer, then they don't want the ordered pair, they just want the integer. So of course you have to follow directions into the computer to get that right. the format. And then the y-intercept is the location where the graph crosses, or they use also, you saw, intersects the y-axis. Okay. And you can see here's your y right here, your y-axis. It crosses right there. Whereas over here, this was the x-axis. This is the y-axis. This is the x-axis. So this is the point. So this is 0, you stay. You don't go right, you don't go left, stay, and you go down, down, negative, because they go down. Yeah. So here we went left, and then we stayed. Here you stay, and then you went down. Okay. And those are characteristics of the X and Y intercept. Remember, the Y intercept we said is the format 0b, remember? Okay. And so 0, -2, and again, whoops, let's see. And so here they want you to type an integer. So the integer, like, well, what I type 0 or -2, what's the integer? Well, they want the y. So this is it's like x, y, but it's also 0, b. Okay, so you want the y-intercept, so you want to type -2 there. That's the integer. Okay, if they want you to provide an ordered pair, then that would be 0, -2. But if they want you to type an integer, it would be the -2. Okay. Okay, let's see what's happening on 46 now. Use the intercepts and a checkpoint, okay, to graph the equation 2x minus y equals -5. So they want you to use intercept, and there's two intercepts. There's the x-intercepts and the y-intercept. There's two of them, x-intercept, y-intercept. Use the intercepts and a checkpoint to graph this equation. Okay, so it doesn't matter which intercept you start with. Doesn't matter which intercept you start with. So if I start with the x-intercept, where does the graph cross the x-axis? And so you're trying to find out what the x is. That means that the other variable has to stay at 0, fixed at 0, and you're trying to find out what x is. So that's why you have to let y equals 0, and then you sub, and you're trying to solve for x. So in your equation 2x minus y equals -5, you have 2x minus y is 0 equals -5. So this falls out. This is just 2x equals -5. And then you have to divide by 2. This divides out. So you have x equals -5/2. Okay, and that is an improper fraction. And if they want a mixed number, you could do long division. The numerator goes inside the house. 5 divided by 2, and it's going to be negative. 2 goes into that twice. That's 4. 2 times 2 is 4. Subtract 1r is your remainder. And then it goes clockwise like this. So this quotient becomes your whole number. Your remainder becomes your new numerator. Denominator is that. So it looks like we're at a -2.5. So when now you know x is -2.5 and y is 0. So this is the x-intercept. So when I'm graphing that, so then when I'm graphing that, this I'm gonna go left 2.5, and then I'm gonna stay. So go left, -1, -2, and then this is -3. So I want 2.5. So -1, -2.5, and I'm gonna stay. So that's -2.5, 0. And that's going to be the x-intercept. See where the graph crosses the x-axis, okay? And then to find the other one, so to find the other one, the y-intercept, which is where does the graph cross, this time the y-axis. Okay, so I use 0b or 0y, trying to find out what y is. So usually they use 0b, but I'll do 0y here also. And so I'm going to let x equals 0. I'm going to short for substitute. I'm going to solve for y. So I have 2x minus y equals -5, and I'm going to let x be 0. So see right here, 2 times 0 minus y equals -5. And 2 times 0 is 0 minus y equals -5. So this falls out, -y equals -5. And you do need to continue this. This is a -1y. And you do have to divide by -1. And so y equals a negative divided by negative is a positive. Yeah. So we have that y equals 5. And so in an ordered pair, when x is 0, y is 5. And that would be the y-intercept. Okay. So then I go back to my paper, and here I would have to stay, and I go straight up. So 0, and go straight up. 1, 2, 3, 4, 5, 0, 5. And that's the y-intercept. Okay. All right. And then they want you to they say something about a checkpoint. I can do a third point just to make sure, which is a good idea. But they say that use the intercepts when drawing the line, like when you're using the graphing tool. And if only one intercept exists, use it and then another point to draw the line. So that's, I guess, where you could also use the checkpoint. Because technically through any 2 points you can draw a line, but they just want a checkpoint. So I'll do the checkpoint on here. So let's see. So let's for the checkpoint, I use randomly. I'm just going to use randomly x equals, I'm going to go out here somewhere. So I already have this. So I'm going to do something down here. So let's see. -1, -2, -3, -4, -5, -6. Let's use x equals -6. Okay, so I'll go to my equation. 2x minus y equals -5. Let's see. And let me do something also. I'm going to stop the share just for a second. Let me do something right quick. There we go. Okay. So I just randomly, since they said something about a checkpoint, I just randomly let x be -6. So I'm going to plug it into my original equation. Remember, this was, for me, this was my original equation. You might have something different, but for my 46, that's what I have. And so everywhere I have a 2, everywhere I have an x, I'm going to sub x equals -6. So right here where I have an x, I'm going to put 2 times -6 minus y equals -5. And this is -12 minus y equals -5. And then I'm going to add 12 to both sides because I want to isolate that. And this will fall out. A number plus its opposite gives you 0. So I have -y equals, this is rule number 2. I'm adding 2 numbers with different signs. So I have to go with the one that has a bigger absolute value. So this one wins, positive. And when I subtract 12 minus 5, looks like that's 7. And so it's going to be a +7. And then you cannot stop at negative y. They never want negative y equals something. They want like y equals something or even x equals something, but not a negative. So this has an imaginary -1 here. So you will have to divide both sides by -1, and that will change the sign to its opposite, -7. So when x is -6, y is -7. So here from 0, 0, you would go left 6, and then you would go down 7. Okay, so I'm going to go left 6. So here, -1, -2, -3, -4, -5, -6, and then down -1, -2, -3, -4, -5, -6, -7. So this is -6, -7. And yeah, that does look right. That does look collinear. See, I'm able to, are you able to draw a straight line? Do you have collinear points? So yeah, using the y-intercept and that x-intercept, and then this randomly chosen third point, you do get something that's collinear, and it's a slanted line because you have x's, and it's not horizontal, it's not vertical. It's a slanted line because your equation had x's and y's in it. So remember the equation that we used, it was, for me, my problem got generated, it was 2x minus y equals -5. Yeah, so that's a slanted line. Okay, now I'm going to go to 47. '47 says they want you to find the x-intercept and the y-intercept for this graph. Okay, so again, more practice on that. Okay, so if I start with the x-intercept, it doesn't really matter which one you start with first, but if you start with the x-intercept, and then of course you have to be careful because there's 2 intercepts, so make sure you put the correct answer on the right description. So the x-intercept, you're trying to find out, well, what is x, and so you let y be 0. So you let y equal 0 and you sub, and you want to solve for x. So you have 6x. Here's your equation. So you have 6x plus 2 times y, and y is 0, equals 24. And then this falls out because any number times 0 is 0. You have 6x equals 24. And then you just divide both sides by 6, and 24 divided by 6 is 4. Yeah, so they do say that the answer is 4 because they want you to type integers for answers. Yeah, so the x-intercept then would be just 4. Okay, so that would be your answer. Okay, so as an ordered pair, we have 4, 0, but they just want an integer, so you would put that on the blank. Okay, and then for the y-intercept, you're trying to find out what y is, so here you have to let the other variable be 0, x be 0, and you're trying to find out what y is. And again, they like to make the reference here 0b for that. And so you have your equation 6x plus 2y equals 24. And what you're going to do is you're going to let x equal 0, and you're going to sub, and you're going to solve for the y. So you have 6 times 0, see? X is supposed to be 0, so 6 times 0 plus 2y equals 24. Any number times 0 is 0. And so this is just 2y equals 24. And then I'm going to have to divide both sides by 2, that coefficient. And 24 divided by 2 is 12. And so the y-intercept is the 12. And as an ordered pair, when x is 0, y is 12 as an ordered pair. Okay, then on 48, it does say use intercepts and a checkpoint to graph the equation. And then they have multiple choices on this one. Okay, so you have 4x minus 5y equals -9. That's what was given to me on my computer here, my problem it generated. Okay, so again, if I start, and it says use the intercepts, and there's 2 of them, x and y. Use the intercepts and a checkpoint to graph. Okay. So again, if I just start same format with X-intercept, and so I'm trying to find out what x is. So I have 4 times x minus 5 times 0 equals -9. So notice here how we have to let y equals 0. This falls out. And then I'm going to have to divide by 4. So x equals -9/4. And if I'm going to make a mixed number out of that, I just do long division. Top number numerator goes inside the house. 4 goes into 9 twice. 4 times 2 is 8. 9 minus 8 is 1. That's your remainder. And I record it clockwise. So it's going to be a negative, see right here, -2 and 1/4. Okay. So when I plot that, x is -2 and 1/4, and then the y was 0. So here I'm having to move, let's see. I'm having to move left, and then I'm staying. Okay, so I'm going to go left, -1, -2, -3. So I'm a little bit past 2, -2 and a fourth. So about right there. So that's -2 and a fourth, 0, which is the same as -9/4, 0. And that's the X-intercept, okay? Okay, now I'm going to find the Y-intercept. So you're trying to find out what Y is. So you let X be 0, you try to find out what Y is. Okay, so here you let X equals 0 and you sub. And you gotta find Y. And they like to use the format 0b for this one. Okay, also. So I have 4x minus 5y equals -9. And everywhere I have an x, I'm going to plug in 0. And this just falls out. And I'm going to just divide by -5. And remember, a negative divided by negative is a positive. So it looks like we have the y-intercept is 9/5. And if I do long division on that, looks like that's 1 4/5. Okay, so in my ordered pair, so I would have to stay, and then go up. So stay and then go up 1 4/5. So stay here, then go up. So here's 1, here's 2. So go up 1 4/5. So 5/5 would be 2. So we're close to 2. Okay, so this is x is 0, and this was 1 4/5, which they also say 1 9/5. And that is the y-intercept. And through any 2 points you can always draw a line, but that's why they're suggesting a checkpoint. So I'm going to use randomly. I see this here. So I'm going to just use randomly 4 x equals 4. And just plug that in. So I have 1, 2, 3, 4. Okay, so let's see. So the original equation was 4x for me, that 4x minus 5y equals -9. And everywhere I have an x, so I'm going to sub x to be 4. And 4 times 4 is 16. And then I'm going to have to solve for y. So I'm going to subtract 16 on both sides. So let me use my finger. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so that worked out nice. you owe somebody 9, you owe somebody 16, now you owe them 25. So you keep the negative, you add, keep the negative. And then now I'm going to divide by -5. And a negative divided by negative is a positive. Same signs produce positive results. So when x, on your x and y, when x was randomly, I just randomly chose x to be 4, then I plugged that in and my y came out to be 5. So at 0, 0, I would have to move right 4 and then up 5. So I already showed you 4 here. Now I have to go up 5. 1, 2, 3, 4, 5. So 4, 5. Yeah, and that looks good. That's a checkpoint. That's my checkpoint. And you can see that we have this slanted line. It's collinear. And that's for the equation 4x minus 5y equals -9. So it is a slanted line. So I don't know, this graph came out really nice. I guess because it was done in blue, I guess. So this one looks nice, not like the other one. So only difference I see is this is in blue. So I must be running out of my other ink. All right, now we're getting to number 49. So fill in the blank in the sentence below so that the resulting statement is true. The slope m, so we use little m in math for slope, not big M, but little lowercase m. The slope m of a line through the distinct points x1, y1, and x2, y2 is given by the formula m equals, and then it has a blank. So what we need to find the slope is the formula. It is m is equal to y2 minus y1 all over x2 minus x1. Okay, that's a definition. Okay, that's a definition. So you're subtracting the y's and you're subtracting the x's, and you've got to do the same order. You start, these subscripts of 1 is because this is for the first point. And see these subscripts of 2? That's because that's for the second point. Those are subscripts. Okay. All right, so now let's look at 50. So you have these 2 points, and this is what my computer randomly generated for me. Got these 2 points, and they want us to find the slope of the line that passes through the pair of points. Or or if it's undefined, then they want you to state that the slope is undefined. Indicate whether the line through the point rises, falls, is horizontal, or is vertical. Okay, so let's see. So to do that, to do this, you could just plot the points and look at your line and see if your line rises or descends, falls, or is it horizontal or vertical. In order for it to be like the horizontal vertical, usually either the x's or the y's have to be identical. So see, these are different x's, these are different y's, so we won't see any of this happening, but it could either rise or fall. So if it rises, it looks like this. If it falls, it looks like this. So when you move from left to right, it rises. When you move from left to right, it falls. So remember, we study graphs. We move, and remember, we study graphs from left to right. And then we have horizontal, and then we have vertical, up and down. Okay. So if you think it out on your graph paper on this one, here you think it out on your graph paper to get to that, what would have to be the same? You would, and I can go back to a past graph to write that comment. Let me do that real quick. See this, see this? Look what's the same. The y's would have to be the same. So you have to have here the same y's. Whereas to have vertical, see, this is vertical. See, you have to have the same x's. To have a vertical line, you have to have the same x's. See that? Okay. And that's why you see we don't have the same x's. So it's not vertical, and we don't have the same um, y's. So it's not horizontal. So it's going to be one of these, rises or falls. Okay. 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 So x1, y1. So label your 2 points as one of them x1, y1, and the other one x2, y2. So this is for the first point, This is for the second point. So x1, y1, x2, y2. First point, second point. Okay. Okay, then that's, you have to use the formula. And then you have to sub, which is short for substitute. Okay, so that's why, it's good if you're allowed to use the printouts. You don't have to have the form memorized. You just go to your pages, and you have to be familiar with your work. And y2 minus y1, x2 minus x1. And I like to kind of do this. Also, I like to do this. I'm highly visual. But see these 4 locations, or these 4 boxes here? This is your minus sign from here. Okay, so you're going to plug in some values. Remember we said plug it in, remember? So we're going to plug in these values here. So so for y2 minus y1 right here, y2 was negative 8 for me, was a negative 8. Take away y1 is 2. And then x2, for me, x2 was assigned negative 4. Take away x1 was negative 6. So I have negative 8 minus 2, and I'm adding, or excuse me, so I'm going to do fix it. Keep, change, take the opposite. Yeah. Okay. And then that gives me a negative 10. So I add and keep the negative. And then I'll do the same thing here. Keep, change, take the opposite. Opposite of a negative 6 is a plus 6. So I'm keeping, I'm changing to a plus sign, and then taking the opposite. Okay. So I'm adding 2 numbers with different signs. So I have to decide on my sign. I have to ID my sign. And then I have to subtract. So I'm going to go with the positive because 6 is bigger in distance. And then when I subtract, 6 minus 4 is 2. So negative 4 plus 6 is 2. And then I'm going to simplify. So negative 10 divided by 2 is a negative 5. Okay? So yeah, I can do a little checking on that. Negative 10 divided by 2 to negative 5. Okay. Also here we want to do a little checking. Negative 4 plus 6 is 2. Negative 8 plus negative 2 is negative 10. So you can go back and do checking. So I always do it first without a calculator, then you can do some checking. But you do have to show your work. You cannot just have negative 5 with no work. You won't get the full credit for that. So you should, jot down the formula and do your substitutions. Show a little work there, okay? You got to show some work. You just can't have the answer and no work. Okay. And then this thing about, does it fall or does it rise? So what you can do without graphing is that because this is negative, this is a negative slope, and because it's a negative slope, since we have a negative slope, then we say that the line falls. Yeah. And it's always, from from left to right when we study the graphs. But it does fall because this is negative. Okay. And even if you were doing a sketch, I better do it on graph paper. Let me see. Go to graph paper. So if I go to 50 and I sketch that, okay, so here -6, so here we go to the left and then we go up. Okay, so at 0, 0, go -1, -2, -3, -4, -5, -6. Then I go up 1, 2. And then -4, this tells me to go also left and then down. -1, -2, -3, -4, and then go down 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so see how the line falls? So if you think about yourself, being on this line, we're walking not upstairs, but we're walking downstairs from left to right. So that means that we have negative slope, and that means that the line doesn't rise, the line is falling, the line falls. Okay, so the picture helps with that, but also just looking at the sign. If it had been a positive slope, then we would say it was rising. Okay, but this is falling. Okay, so that's 50. Okay, 51. Fill in the blank in the sentence below so that the resulting statement is true. So in order to graph the equations of the form, excuse me, in order to graph equations of the form ax plus by equals c using the slope and the y-intercept, we begin by solving the equation for, and then they have blank. Okay, so let's see, ax plus by equals c. So in order to graph the equation of the form using slope and intercept, okay, so that's called slope intercept form mimics, slope-intercept form mimics this, y equals mx plus b. And so since it mimics that, you can see here that we need to solve for y, So in order for us to solve this for y, we need to isolate this. So in order to isolate this, we have to move this. So I'd have to subtract ax on both sides, and this would fall out. So then I have by equals, and I want to mimic this. See how they put the x term first? So of these two, I should put that negative ax term and then the whatever the c is. And then to continue solving for y, I'd have to divide by that b in 3 chunks. So divide by that b in 3 chunks, not 2 chunks, but 3 chunks. So this is 1 chunk, that's 2 chunks, that's 3 chunks. So we have y is equal to negative a over bx plus c over b. And then you simplify if you could, or reduce if you could, or simplify. So to answer the question, in order to graph the equation of the form ax plus by equals c, using the slope and y-intercept, we begin by solving the equation for y. Solving the equation for y. And then we need to do that on 52. If you look at 52, two x plus 5y equals 20. And they want you to solve for y. Yeah. So to solve this for y, you need to isolate this. So you need to get this out of the way. So you need to start by doing minus 2x, and this falls out. So you have 5y equals, and then you should put this first, because you want to, when you're solving for y, you want to mimic y equals mx plus b. They put the mx term first, so you need to put the negative 2x, and then this stands for your constant. This is standing for your constant, which is a positive 20. For me in this problem, this is what I got generated for the problem when it gave it to me. And now I'm going to divide by 5 in 3 chunks. This slope, this is your slope, your m, that doesn't reduce, but this simplifies. 20 divided by 5, that's just 4. So you do want to simplify that. If this could be reduced, we reduce your slopes, but that can't be reduced. We always reduce our slopes if possible. So y equals negative 2/5 x plus 4. Okay. And if we're not asked to graph this, but if we were to graph this, what you would do to graph, you would have to plot the y-intercept first. So you'd have to plot 0, 4 from here. And then you'd have to honor your slope m equals -2/5. So this would tell you that from here, from 0, 4, then honor your slope from 0, 4. So m is equal, this is your m. See, y equals mx plus b. Sometimes this is positive, this is negative, sometimes this happens to be positive. And m, you'd have to, from 0, 4, you'd have to move down 2, because this is negative. So, m is rise over run. M is rise over run. So sometimes you have to go positive, sometimes you have to go down, and then sometimes you have to stay. And then on the run, if it's positive, sometimes you have to go right, sometimes you have to go left, or sometimes you have to stay. So it just depends on their signs, but it's a rise over run. So here on the 5, you have to go right 5. So you go down 2 and right 5 from 0, 4. If they were asking to graph it. Okay, so 53 says fill in the blanks in the sentence below so that the resulting statement is true. The slope-intercept form of the equation of a line is where m represents the and b represents the. All right, okay. So the slope-intercept form of a line is, excuse me, y equals mx plus b, where m represents the slope and b represents the y-intercept. So that's 0b format. Okay. Okay, and then if I look at 54, excuse me, 54, excuse me, so let's see. It says write an equation for the line shown on the right. The equation of the line is, let me have a blank. Excuse me. Okay, let's see. Let's see if I can see my line. Yeah, so this graph came out pretty good. Okay, so if I try to recreate that on my paper, you see this point here? So I can do that here. 1, 2, 3, 4, 5, 6 here. So this is x is 0. See, you're not going right or left. It's x is staying. And then you went up. And you went up 6. So that's that point. And then this other point, see that right there? Okay. So here's x is 1, and you go down 1, 2, 3, 4, 5, 6, 7, 8. So 1, and you go down 8. Okay, so you went to the right 1, and you went down 8. That's that point there. Okay, and then that's that line falls. This line falls, so it's a negative slope, okay? And they wanted to know the equation. Okay. Okay, so I think I'll do this on here instead of going back to the other paper. Okay, so I know y equals mx plus b. So I think the easy part is probably the b, because the b is the y-intercept, which is the location where the graph crosses or intersects, excuse me, the y-axis. Okay, so you can see that it intersects or crosses the y-axis. See right here? And that's at positive 6. So that means sometimes this is positive or negative, and for us it says positive 6. So that's this part here. Okay. Excuse me. Okay, now for the m, what we'll do here is we can find the m by using that slope formula. Yeah. So remember m was equal to y2 minus y1 over x2 minus x1. Remember that? Yeah, sure. So we can use that to find m. Why not? Yeah. We need to do that. Yeah. So I'll just make this the first point. Doesn't matter. One of these is the first and one's the second. So I'll just make this x1, y1. And I'll just say that's the first point, because I already looked at the y-intercept anyway, 0, 6. Excuse me. And I'm going to make this x2, y2, which is the second point. So now I'm gonna plug those in, okay? So I'm gonna do that down here. So 0, 6 was the first point, x1, y1, and then 1, negative 8 was the second point. So I made that x2, excuse me, y2. Excuse me. Okay, so I'm going to do a substitution. So y2 is negative 8. So put that right here, see? y2 minus y1 is 6. x2 is 1. Take away x1 is 0. And I'm going to take the opposite. So change that to plus, and then take the opposite. And then down here, I don't need that only because this is 0, so I don't have to do keep change, take the opposite because that's 0. So 1 take away 0 is just 1. And here I'm going to have to add and keep the negative. It's like you owe somebody 8 and you owe somebody 6, 8, 9, 10, 11, 12, 13, 14. So this is a negative 14 over 1, which is just going to be negative 14. Okay, so that's your slope. And so that goes over here. See, for your mx. So it's a negative 14, and you do have to put the, see, you do have to put the x. You just can't put negative 14 plus 6. You do need the x, but that's where it's coming from. Okay. I think also the other idea of slope, see, m is also rise over run. So rise over run. So you can see to get from this point to this point, you had, and remember this is the y-intercept. So we move, remember this is the y-intercept. So from here we went down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We went down 14. So and then we went to the right 1. See that? So on the rise over 1, we went down and then we went to the right. So we went down, that's a negative because we went down 14, and then we went to the right, that's positive. And you see negative 14 over 1 is negative 14. Okay. All right, class. Okay. So that's the equation of the line, that y is equal to negative 14x plus 6. Okay. And I think this is more reliable only because when you do this, you really need a big picture of your graph. So, but that's why, I sometimes when that's why you have your template, right? So that you could show your work. Because it's hard to do it from the screen, right? Without, I recreate the screen on my paper, and then I'm able to count, okay, back and forth. Okay, now we're going to look at 55. So 55 says that they want you to find the equation of the line. I think I'm going to have to do this also on the paper because I have a graph. So you can see how I have this here. Excuse me. Okay, and this graph came out good. See, it's a good graph. Yeah, so I'm going to do the same thing. I'm going to recreate it so you can see how it, here at 6 and then here at 5. Okay. Okay, so what do we say? We said, what do we say? 6. 1, 2, 3, 4, 5, 6 right here. That's the point. 0, 6. So you always start at the origin, you go right or left. This one stayed, and you went up 6, and that's the y-intercept. So I'm going to say that's also the first point. So I'm going to say that's x1, y1, okay? And then the second point we said was at 5. 1, 2, 3, 4, 5 right here for the x's. So here you started the 0, 0 and you went right, and then you stayed for your 0, and that happens, by the way, to be the x-intercept, and that's going to be also my second point. So x2, y2. Okay, and I'm going to draw the line. Okay, so you want to think, y equals mx plus b. And the easiest thing to do is to identify the y-intercept, which you can see here also happens to be 6. So I think that's just coincidence, because the other problem, don't think that it's always 6. The other problem that we just did also happened to cross at 6 also. So just a coincidence. Positive 6. So not negative 6, but positive 6. And then the m, y2 minus y1 over x2 minus x1. So this is mx. So now we need to find m next. And when we do, we're going to put it here. When we do, we'll put it right here. So I'm going to find m using this formula, slope formula. So y2, see, y2 is right here, y2 is 0. Take away y1 is right here, which is 6. x2 is 5. Take away x1 is 0. So 0 take away 6 is negative 6. 5 take away 0 is 5. So it looks like our slope is negative 6/5. That's your m. Yeah, and we only reduce slopes. We only reduce slopes, but no mixed numbers allowed for slopes. So even though this isn't proper, and we know in the past we were talking about mixed numbers doing long division, we're not allowed to do that for a slope, because a slope is a rise over run, a numerator over denominator, rise over run. We don't have any format for a mixed number, that whole number in there. We just keep it as a rise over run. In this case, it goes down, and then goes down 6, and then it goes to the right 5. So my m is negative 6/5 with respect to x. So then you would look at all your answer choices and then pick the best answer choice, where you have the negative 6/5, and you have the plus 6. Okay, so again, if you're trying to eyeball the slope, because m does equal, like we said, rise over run, and this is from the y-intercept, which was 0, 6. So from the y-intercept to get from this point to this point, your rise over run. So your rise, you had to go down. Sometimes on your rise you go up, sometimes you go down. So you went down 1, 2, 3, 4, 5, 6. So that's why it's a negative, -6. And then you went to the right 1, 2, 3, 4, 5. So on the rise you went down and then you went right. So that's why it went down. That's why it's a -6, and then you went right 5. So see, these two here, they match, they're correct, see? All right. So you just have to communicate, you know, do this on the test, show this. Okay, if you're going to do this on the test, show this. I can follow that on your picture. But then, you should sketch your picture because you have on the computer, so you need to have grab paper to sketch it. And it's likely that when I make the test in the test template, I'll have some graph paper in there also. Okay, but there's the equation. There's our answer. I want you to find the equation. There it is. So this is y is equal to -6/5 x plus 6. Okay, and that's called slope and then intercept form. That's called slope intercept form. So at first when we were graphing, we had some tables, right? So earlier when we were graphing, we had an equation and they want you to make a table, and they said make x this, make x this, make x this. And you plug it in, you get a table. This is a table. But now we're graphing, but now we're not using a table. We're using this idea of slope intercept form. So you identify your intercept, and then you see to get to the next point, another point, you use the idea of slope, the rise over run. Okay, so sometimes you rise up, sometimes you rise down, and then on your run, sometimes you run right, sometimes you run left. If you run left, then then that can be negative if you run left, right? Okay, all right, so that's 55. And let me see what 56 is. So this can be 56 then. And they want you to find the slope they want you to find the y-intercept of the line. So they have y equals 9x minus 11. All right. So remember, we're going to use a slope intercept form. So remember, y equals mx plus b. So then your m is 9. So the slope of a line is, and they say type an integer or a fraction. In our case, we have an integer, not negative, but positive 9. So that's integer. And then the y-intercept is, and they want you to type an integer or a fraction. So that was, let's see, this is slope. So then the y-intercept is, this is y-intercept. And really, you know, really on your y equals mx, m could be positive or negative, and b could be positive or negative. So you can see here that, see, it's a negative. So the y-intercept is going, and you're saying type an integer or fraction. So we're going to put negative 11 for that. Excuse me. Okay. We're just looking at my original printouts, and let me see. Let me see. Okay, so it's just that what threw me off was that this says 7, and this should be what got chopped off. I don't know why. That should be 57 was this. So that's the next one. It's 57. And yeah, that's what threw me off. So you see, that's a real light. I can't see that. So that's 56. So I'm not sure why that got chopped off. Yeah, so that threw me off. Okay. Okay, so now we do 57. And they say, and on 56, they didn't want us to graph it. They just said find the slope and the y-intercept. And you know, if you wanted to graph it, you would have to graph this. I could make a comment on that. Let's see. If you, they're not required to graph it, but to graph it, if you wanted to, you would have to plot the y-intercept first. So you would have to plot 0, negative 11 first. And then from there, from 0, negative 11, then you would move via your slope, which is rise over run. And so for us, our slope is 9, so that's 9 over 1. And so then you would have to, from 0, negative 11, from that point, you would have to go up 9, 9 up, and then you would have to go right 1 right, and then from up 9 out 1, then you could plot that second point, and then you could draw a line connecting. You're going to plot 0, -11. That's your first point, and then you're going to go from there up 9, right 1, and you plot your second point, then you can draw your line. Okay. Okay, and then 57. So 57 says they want you to graph the linear equation using the slope and the y-intercept. So y equals -4/5 x plus 2. Yeah, and they have the negative like right smack them in the middle. And what you should do is rewrite it a little bit. So you should just push it to the top, and that's equivalent. Just push it to the top, okay? It's because right now they always record it in the middle and just push it to the top. So then to graph, you would have to plot the y-intercept first. So that would be 0, 2 from here, see? And then from 0, 2, you would have to move via your slope, which is m, which is rise over run. So see this, see that? So -4/5. So that means you'd have to go down 4 and then to the right 5. Then you would plot your second point. Okay. So on my paper here, this is a good graph. That came out good. That Cartesian coordinate plane. So I'm going to use my graph paper. I guess I could have graphed it. I guess I also could have graphed it on that other sheet from the review. It's fine. Okay, so I'm going to plot the y-intercept first, 0, 2. So this tells you to stay and then you go up 2. So stay and then go up 2. So 0, 2. So y-intercept. Okay, then from there I'm going to go down 4 and to the right 5. Down 4 and to the right 5, honoring my slope. So from here I'm going to go down 4. So 1, 2, 3, 4. So down 4 and into the right 5. So 1, 2, 3, 4, 5. So again, From 0 to go down 4, 1, 2, 3, 4, and write 1, 2, 3, 4, 5. And that's the point 5. So this is 5. And then we have to go down -2. And then I can, through any 2 points, you can draw a line. They didn't ask us to do a checkpoint here, so because we're using slope intercept, y equals, remember, -4/5 x plus 2. So that negative that was in the middle, I just push it to the top. Okay, apply it once. Don't overuse it. Okay, so you plot y-intercept first, and then you plot 5, -2. That's your second point. Okay, so we use y equals mx plus b idea. Okay, so this is 0b. Okay, 0y. Okay, that's 57. Okay, and then 58. Oh wow, this is the last one. Yay! All right. So 58 says, okay. I think since that's the last, I think I'm going to do 58 on this paper here. So for the equation, complete A through C. So they want the slope, they want the y-intercept if you have one, and then they want you to graph it. Okay, so we have this equation. See, 4x plus 5y equals 20. So I'm going to do that last one here. 4x plus 5y equals 20. Okay, so I'm going to have to solve this for y. So I'm going to subtract 4x on both sides. I'm going to, because I want to solve for y to mimic y equals mx plus b. So this is -4x plus 20. I'm going to divide by 5. And 20 divided by 5 is 4. Okay. So put the first part says put the equation in slope intercept form by solving for y. Yeah, that's what we did. This is called slope intercept form. Yeah, so this is part A. So I'm going to go back and put that here. Y equals -4/5 x plus 4. Yeah, and you can put the negative either in the middle or on the 4. Just don't overuse it, okay? And then part B says that identify the slope, okay? So this is y equals mx plus b. So your slope, m, this is m. So no x, that's your slope. So if I see that is right here, which is negative 4/5. So write it like that. So that was part B, that was your slope. And then part C, or still part B, they want you to identify the y-intercept, and they want an integer or a fraction. Okay, so y equals negative 4/5 x plus 4. So y equals mx plus b. So they want this b is the y-intercept. Okay, so that means they want that right there. They want a integer or simplified fraction. So that would be, that goes here. That's 4. Okay. Okay, and then the last thing they want you to do is they want you to use the slope and y-intercept to graph the linear function. Okay, so that's part C. Okay, so remember, to graph, we first want to plot the y-intercept, which is going to have to be 0, 4 format. So you stay and then you go up. So right, you stay and you go up. Oh, and look how this is increments of 2. Be careful here because this is 1, 2. Okay, so go up. So 1, 2. Okay, that's good. So 0, 4. And then, and that's your first point. And then you move via your slope, which is m. Remember, m is rise over run. So for us, we have a negative 4/5. So you're going to have to go down 4 and to the right 5. And you do that from 0, 4. So from 0, 4, you're going to go down 4 and to the right 5. And you go down because it's negative here. It's negative. So go down 1, 2, 3, 4, and then go to the right 1, 2, 3, 4, 5. And this is the point 5, 0. So here you go to the right and then you stay. Okay, and that's your second point. Whereas here you had to stay, then to go up on that one. That was your first point. That was your y-intercept. Yeah, and then you just connect the line. Okay, and then that's y equals negative 4/5 x plus 4. That's the name of your line there. Okay. All right. And then that'll do it. All right. All right. So when you're studying for your test, you have your own print it review that y'all printed. So it'll be similar to the work I've done, except I'm sure the computer randomly generates different numbers for you, but it's the same type of format. And then, like I said, I know there's just a lot of problems 58, and it's because I also had vocabulary and concepts and definitions on there also. But I will pick a total of about 20 problems is usually a good rule of thumb. Sometimes it might do 20 to 25, but usually 20 is a good amount. And I'll try to spread it out because there's chapters 1, 2, and 3. So I'll try and do uh, like 6 or 7 from chapter 1, 6 or 7 from chapter 2, 6 or 7 from chapter 3. So, because 6 times 3 is 18 and we want 20 problems. So a couple of chapters might have an extra problem in there for that. Okay, but good luck with your studying, and I hope this helped. Okay, all right, take care, feel well, and stay healthy. Okay, bye.